Welcome everyone. It's Friday afternoon down here in downtown Honolulu. Ted Ralston with our show, Where the Road Leads. Today we're going to talk about that road that leads to the beach and beyond, and we'll talk about the reef, talk about the inshore waters, and talk about the other factors that we often don't necessarily recognize as part of the ecosystem of the marine environment. One thing this show is noted for, of course, is the quality of our guests. Last time we had Jay Fidel on as our guest, who owns the studio. And today we have on Dr. Cynthia Hunter and Dr. Craig Glenn, who've taken time off from their roles at UH, and they've volunteered to come down here and talk to us a little bit about some of the factors that are affecting us in the domain of King Neptune as he comes ashore here in Hawaii. We talk about technology on this show, technology affecting Hawaii, Hawaii affecting the Pacific and the Pacific Rim. Technology isn't necessarily, as we've said so many times, just circuit boards or high-level processors and this sort of thing. Technology is really the art of solving problems with different methods to solve those problems. And one of those methods is getting people together. And I think we are getting these two together. Perhaps they live on the same campus but haven't had a chance to work together. Maybe we can do something about that. In any case, the thing that brings us all together is this little guy here who you've seen on this table many times before. Margie and I just got back from California yet again with an exercise there, and we're going back in one in February that I'd like to bring you up to speed on. It's going to be in Alameda Bay in San Francisco, all maritime work, so we can talk about that. Anyway, let's think about, once again, about the marine environment in a systemic or systematic way. I think those of us who are water users think of it as paddlers or surfers or something. We don't really see the whole picture. You, in my knowledge of working with you two so far, I see this incredible new way to look at the marine environment in a system, as an ecosystem. And so dependent upon what takes place Mauka, and probably dependent on what takes place out in beyond Makai into Moana, so to speak. So the whole picture flows together in some way, or doesn't flow together, depending on what we do, what we treat it. And so let's talk a little bit about that and how we see technology coming into the picture to at least inform us about what's going on, if not help us in some way. So let's turn to Cindy first and get your perspective, Cindy, on just how the Marine Options Program works and how that allows us to see these things and bring people into the picture.
Great. Thanks, Ted. It's really fun to be here this afternoon with both of you. I'm a coral reef ecologist. I teach at the University of Hawaii in biology, and also I'm with the Marine Option Program. So I work with undergraduates and graduate students alike. Back to the coral reef question, which is what's bringing us together today. It's been a tough year for corals in Hawaii. In the middle of July, we had some really heavy rains, and corals don't do well with fresh water. So that was one of the first issues, especially in the north end of Kaneohe Bay, and we'll talk more about that later. Another area of interest where you and I have worked, Ted, is in Lanikai. Beginning on actually September 21st, after the day before, we had seen a peak of temperature at about 86 degrees.
What do you expect it to be normally there?
About 83.
So 3 degrees difference is significant as far as if you're a coral, you care about 3 degrees.
That's right. You also might care about how long it's been warming up. That we appear to have exceeded a threshold of 86 degrees on the 20th. On Sunday, I went snorkeling, kind of just for fun, in Lanikai, and recognized that, wow, a lot of the corals had shown a sign of stress.
And they stress out that quickly?
They stress out that quickly.
And these are different species of coral, perhaps?
Every species, except for 1 or 2, appears to be involved in some degree. These are the major reef-building species in Lanikai and Kaneohe Bay. We've had reports from other places around the state, not everywhere, and certainly not deeper than about 60 feet depth, but in the shallow, calmer waters, this is where the coral bleaching issues began.
Do they have a chance to, can they come back?
Boy, we're hoping so. We've already started to see a beginning, perhaps, of recovery on some of the species that began showing signs of stress first in September, but we're also seeing that the bleaching is spreading to more species, more colonies, and broader geography, and even deeper depths.
Why do you think it would be Lanikai and Kaneohe Bay? Why would that be the focal center?
Right. We think it's because we had a pretty still summer, trade wind-wise, so there wasn't a lot of wind to move water around. So water temperatures were elevated, and when it's calm, the UV from the sun, which is also damaging and synergistically with high water temperature, caused extra stress to the corals.
So the coral would be better off if we had a wave motion generator in there of some kind that would keep the stuff stirred up.
Or everybody just gets in and kicks with their fins.
We need a lot of swimmers, a lot of paddlers down there. We need to improve the
water
the
circulation.
reach of the canoe clubs and get them out there and stir the water up.
That's right.
Great.
I just heard today, real quickly, from a manager, Dr. Bill Walsh at DAR in Kona, that they're seeing very little bleaching there. And think about the coral reefs off the Kona coast. They're deeper, and there's a lot more water circulation. And the temperatures have remained below 83 degrees or below also.
We were out with you in Kaneohe Bay back in June, I think it was. Did some surveillance and such with little airplanes like this, little UAVs. We didn't see much bleaching there, did we?
Hadn't started. Everything was fine.
So R44 is now got some damage in it?
R44 is a mess. The heavy rains were July 14th and 15th, and the fresh water, as I said, corals don't like it. It didn't appear to come down as a sheet flow, and that's why I can't wait to hear what Craig's got to say to us.
Okay.
It seems
You're going to hold him responsible now, aren't you?
Absolutely,
okay.
Because he's got some keys. And actually, I have to say, when you called us both up, we got on the phone to talk. We have known each other for a while. Are you going to go on? I don't know. Are you going to go on? I don't know. No, let's do it.
Okay.
But then we started talking about
Yeah.
even more research overlap and have some ideas that we want to run by you.
Oh, and let's put those ideas out in front of the people who are watching this show, and if we can get kids in the, in the high school range interested, and maybe undergraduates who want to move over to the marine options or the geology program.
Absolutely, yeah.
We'll put that. We'll give them an application right now, right?
Yeah, right. Yeah.
Okay.
We'll sign you up.
Call me up, right?
Sign me up. Okay.
So the link is that we saw water moving. It's called submarine groundwater discharge.
That's right.
Not sheet flow on the surface of the bay, Kaneohe Bay, but rather it came underneath and percolated up. And the corals had nowhere to go. Corals can't run away. They're
That's right.
stuck on the bottom. So they began to die and show
From the
signs
bottom
of
up?
stress from the bottom up.
Wow. And how did you determine that subterranean groundwater discharge? Got your terms. Was that just a...
Well, she says so. We usually call it submarine groundwater discharge.
Submarine.
And actually, very often it flows as a sheet across the surface because it's fresher water, it's brackish, and it floats. And it often comes out along the shore. In most cases, it forms a huge sheet which flows across the surface. But a lot of what we're finding out now is occurring offshore. It gets that term from 50 years ago called submarine groundwater discharge, when they first were discovering such things as deep water or as springs off the coast of Florida, for example. So you have springs coming out in the middle of nowhere, and it seemed very strange. But in Hawaii, very often it's very located very close to the shore. And I have a picture I can show later where you see it actually comes out from the sand, when it's at beach.
Well, we've been getting these reports for years from our grad students
Yeah.
who are way out in the channel in Kaneohe Bay, which
Yeah.
is how far from shore? A couple hundred meters?
Yeah, sure.
And they're saying, wow, the water's cold, and they've
Yeah.
measured the salinity is lower.
Sure, yeah.
And it's not lower closer to shore, it's
Yeah.
lower way out by the
It's
channel.
different
How does that
everywhere.
happen?
Yeah, I mean, it's different everywhere. And so there are conduits in Kailua, Kona Harbor, for example. There's lava tubes, which are direct feeds. And so you see boils of this groundwater discharge coming out. And off Aina, there's similar cases like that as well. And in the reef situation in Kaneohe, who knows? We haven't even done it yet. We've
But
been
we're
working.
going to.
Yeah.
We don't understand it. In Cavello Bay, there's places where people still go today, swim out a 5-gallon jug and collect fresh water.
I understand they do, but
There's
it's an
pictures
old
of-
Hawaiian practice.
Pictures
right?
of cattle
Yeah.
out in the ocean and
Yeah,
even in
horses
Kailua.
drinking water.
Drinking water, right.
Yeah.
So that's interesting. Cattle are a sort of a piece of technology here. They're a marker of the cold water. People swimming around are the marker of the cold water. If Phil McGilvery was on the line, he'd tell us about certain of the fish species who become a marker of that water as well.
Right.
So we're just, from what I'm hearing, we're kind of like at the beginning of the larger discovery of what the markers are
Yeah.
and how to physically model
Mhm.
these issues.
And
Right.
what the connections are.
Yeah.
But so connecting here That's where it all started, Jay, right here in the studio.
Well, actually, it goes back further than that.
Does it?
I
Okay.
mean,
I was just trying to get credit for it, that's all.
to be
Great.
honest, I mean, the Hawaiians have known forever the submarine groundwater discharge. I mean, there's different kinds of fish ponds. Much of the feeding of the Hawaiian people came from harvesting fish in fish ponds. And many of those fish ponds are located very close to shore, and they were tapping the nutrients that were feeding into that pond and you know, doing their cultivation, harvesting of the fish in there.
So those people and their application of their insight and knowledge become a marker. Some of the animals are markers, the fish and the animals, and this guy, where we used this with Cindy about 2 or 3 weeks ago, and we'll show you some of that video on the next, after the break. And we've used it with Craig off Kahe Point to begin calibrating infrared sensors, which we'll talk about as yet another marker and a use of technology here after the break. We'll come back in 30 seconds.
Okay.
Hi, I'm Donna Blanchard. I'm the host of Center Stage here on the ThinkTech digital series. The show is every Wednesday from 2 o'clock to 3 o'clock, and I want you to watch this show because I think that when we talk with artists on the show about what they do, how they do it, and most importantly, why they do it, I believe that it resonates within each of us, and we find something inside of ourselves that brings us closer to all of humanity. That's what arts are there to do, and that's what I'm here to do on this show. That's Center Stage. It's on every Wednesday from 2 to 3 o'clock. I hope to see you there.
We're rolling. Back on, folks. Ted Ralston here, downtown Honolulu with the ThinkTech Hawaii studios. Our guests are, we'll call you marine scientist as a general category, geologist.
Sure, yeah. Okay, whatever you want to call it.
Dr. Cynthia Hunter, Dr. Craig Glenn from the University of Hawaii, who once again have kindly taken time off from activities up in Manoa and come down here to join us in ThinkTech Hawaii studios. We're talking about the systemic and systematic look at the marine environment, how it relates to the inshore marine environment, how it relates to the upland and the deep water environment, talking about technology and markers. And so we'd just like to show you something here that we discovered totally by accident. Craig, I don't think we've shown you this yet. Maybe
I haven't seen this, no.
PowerPoint. This little guy here, this little UAV. Jay Feinell's favorite things are UAVs, so we always bring them in here. This one happens to have it's got 3 cameras on it, if you can see that here. And one of the cameras has the infrared filter removed, so that instead of true color, it's what you call color IR. Some of the longer wavelength energy comes in that would normally be filtered out for a true color picture. And lo and behold, by absolute accident, we discovered a very strong signal that we don't understand yet, coming through in the near infrared area.
Okay.
And furthermore, we found that in testing, the turbidity which prevents or inhibits good observations from in the water is somewhat improved by looking down from the top.
It's been remarkable.
Okay, remarkable. So let's just take a look at that tape and we'll talk through it. If you can roll that, Zuri. Okay, we're going to be a minute here, folks. So what this is a look at some of the coral in an area that's calibrated, so to speak, offshore of Lanikai, about 120 yards offshore or so. Go right there. If you can just hold that right there, Zuri, that's good enough right here. What that is a what? Okay, let it roll again a little bit then.
If you would, please. Yeah.
And Cindy want to talk through it.
Sure. So these are corals, big bommies we call them. Huge colonies that may be 3-4 meters apart, across. You can see the one there that we call Mickey Mouse, with the 2 kind of purple ears on it. Oops. So these colonies are very complex. They may be made up of many species.
Let it play, that's fine.
Yeah, please do. I can use my hands to create them too. But they're very complicated and challenging to measure, especially when you're in the water. Most days in Lanikai, the visibility, is just not that great. Maybe a couple meters at the most. So we've been trying to survey the stress response of the corals in Lanikai. And it's hard when you're in the water, bouncing up and down, and trying to get measurements of all the dimensions.
Here's the Mickey Mouse coral, and notice that incredibly brilliant
Pink.
color
right?
coming out. Yeah, it's got radiation
We were
coming out of it in a
absolutely-
range we did not expect.
Right,
Yeah.
And
absolutely
with the
surprised.
true color, that doesn't show up at all.
That's near infrared that you got,
Yeah,
right?
right.
Okay, right.
So
So
we're
it's very
getting
close
some
to
action
visible,
there.
but a
So,
little bit set.
and that shows the stressed areas of the corals in
Mhm.
upper surfaces. At the same time, we can use this to measure the size of all of the corals that you can see so clearly. You can see the bleaching here too, the lighter colors, the white, light yellow colors that you see. But you can see the size of the colony so clearly from the air, and that takes so much time to measure them underwater.
So just taking inventory is something that we can get out of this as well that we hadn't
Absolutely.
thought of.
That's right.
Now we need, what grad students are good for is taking this problem that we don't quite understand and calibrate the cameras, maybe tell us some other bandpass filter ranges that would be more useful, and then turn this into a marker system and an inventory system that would dramatically cut the time, and it would allow us to get the big picture quicker, and then we could repeat it like on a monthly basis or whenever the temperature and the atmospheric conditions call for it.
Yeah.
So there's one of our swimmers. That would be you, I think, or...
I think that's Kitty Courtney, actually.
Yeah. Okay. Well, we can go ahead and end the video, Zuri. Anyway, just wanted to show you that this is just a pure accidental discovery.
But a great
So
tool.
now we have to go and turn that into a grant or something and get a project going
Yeah.
that does this thing scientifically and properly.
Yeah. It seems like this monitoring part is just going to be absolutely phenomenal.
We're hoping to monitor the recovery.
Yeah. I mean, can't you actually measure how much bleaching is taking place on any individual coral with
We
this?
don't know yet. We need to calibrate.
Yeah.
And it's really difficult to do in the field without removing a hunk of the coral to take back to the lab so you
Right.
can really quantify
Uh-huh.
things. So we're looking at new ways, new technologies
Yeah.
to do this kind of
But when I was looking at the image, it looked like part of it was pink and part was not. So
Right.
the pink was the
Absolutely right.
bleached part. I mean,
Yeah.
So you could
Yeah.
digitize it. And,
But we also ran it with another camera that has, I thought was a higher tech camera, that is similarly modified with the infrared filter removed, and it didn't show anything. So if we can calibrate the two cameras, we have the first piece of data already on the table.
Yeah.
What's the bandpass? What's the wavelength where that radiation's coming from?
Right, right.
And then that would lead to like a multispectral assessment
Uh-huh.
to figure out the right band.
Right.
But the band may be a function of the growth or the dying cycle of the coral.
Mhm.
Could be that is the band you want to pick to get the best marker.
Right.
There could be water depth, water column issues that are there. So we need to do a good parametric study to understand what that correct bandpass is. Modify cameras to that with that type of a filtration system. Then we've got a great marker.
Right.
Well,
yeah.
the neat thing is that this can fly so low. You couldn't
Yeah.
do this from an airplane.
No, not
But
at
you
all.
can get, how
Right.
high were you flying?
We were flying 20 feet high, 20 feet off the water.
So the resolution that you can get from that elevation is what's made this so
Right.
useful and important.
That's a good point. I like that point. So I'll just make it, I'll steal your point and make it, that the point is cheap, inexpensive cell phone type cameras
Right.
can be very useful when they're down close, just because the pixel size on the surface is very small, and a low resolution camera can do the same job that a satellite can do at 5,000 times the cost. So we have a whole new game here in town in terms of informing ourselves, collecting information, developing markers.
Right.
And you had some ideas in the world of the submarine groundwater discharge, your guilt part of this whole trip, that you're
What's my guilt trip?
causing Cindy's corals to go bad.
Well, I'm not responsible for temperature changes of the ocean.
But just fresh water.
Just the fresh water, okay.
That's my responsibility. Okay, yeah.
Yes. Do you want to use the graphics to take us through what we're going to
Sure,
talk about here?
yeah, we have, okay. If you get those on.
Oh, here's some of the images
Oh, wait, okay.
of the corals. This is what it looks like underwater
Okay.
on a pretty darn good day with, again, some more technology. This is an SLR camera with a big fisheye lens on it. But you can see what we're talking about in terms of complexity, how much time it will take to measure each of these
oh my
colonies
goodness,
and
yeah.
assess the amount of bleaching that varies between the species. and even within colonies.
What strikes me here is that the color infrared, what we would like to do is that Mickey Mouse or which particular
This
coral
is not Mickey Mouse. Maybe we can get Mickey Mouse to pop back up?
What we should do is we really have to do a good scientific comparison here and understand how that turns into the pink color
and
on the false color.
Right. And we got those images yesterday.
Ah, okay.
And last month.
We have to go out and fly it again because they may have changed
Let's
the
go.
infrared response.
Can't wait. Yeah.
So, Craig, again, you're responsible for part of this. So, you
Yeah.
and your submarine groundwater discharge.
Yeah. Can we get the,
How do we get the
a few
PowerPoint up,
slides
Barry?
going here? PowerPoint?
There we go.
There
Here
we
we
go.
Yeah,
are.
okay. So,
Okay, great. So that's Lani Kai.
Could be almost anywhere. This is anywhere in the Hawaiian Islands. This is actually Hualalai up here, up on the west side of the Big Island. But it shows schematically what we're talking about with this groundwater flow, what we call submarine groundwater discharge. And basically, all the rain, this part of the Big Island is basically, it has no stream. So everything that we see, all the water that's leaking into the ocean is coming from rain that infiltrates into the land and then percolates through the island and exits out through it. And this is a phenomena that takes place throughout all coastlines in the world, but it's very important in the Hawaiian Islands in particular. So basically it's all the water, anything that does not flow off as a stream flows out as this thing we call submarine groundwater discharge. So here's this a cross-sectional through the island, and you see these arrows are showing where the groundwater is flowing out underneath and then it exits along the coastline. If you have lava tubes, et cetera, it may exit out further as well. At the same time, there's seawater which is brought in underneath this layer that's sucked in underneath. So what happens is we have groundwater that's flowing out through the island. Through the top, it floats buoyantly on top of the water and on top of the seawater, which flows in underneath it. And what we do with using infrared technology, like you're using here, what we have been doing for the last 10 years is using large aircraft to do large-scale mapping, and we use the temperature contrast between the ocean, which is generally warmer in the cold water as it enters as rain. It's relatively cold, stays cold, and exits through the coast.
What's that temperature difference? It's only a couple of degrees.
It's only a few degrees. Yeah, it could be maybe 5 degrees Celsius.
So we have to have very sensitive instruments to pick that up.
Yeah, well, we can measure about 0.1 degrees Celsius with the instrumentation on the airplane, but it's only as good as we can calibrate it on land or in the ocean. So we put out thermistors, et cetera, to do that calibration. So this is an illustration here. Here's our aircraft. We have an infrared camera located in the belly of the aircraft, and it's measuring the temperature ramp of the ocean underneath it. So the infrared spectrum itself only measures the top 1 millimeter of the ocean. It doesn't penetrate through, unlike what you were doing here with the near infrared. You can get a little bit deeper. Yeah, right. Yeah. You get a little bit shorter wavelength, so you can get deeper. And it says here 3.2 resolution, so that's 3.2 meters on a side is our sort of pixel size, flying at about 7,000 feet though. And we get 0.5 degrees Celsius resolution, and that's based on our thermistors we have in the ocean for our intercalibration. And we also intercalibrate in the airplane constantly with the black body technology as well, so we know what we're doing. And there's a wide variety of interdisciplines. It's truly become an interdisciplinary science. We're mapping all this groundwater discharges that exits the coastlines, but we're also interested in, what's the water that's flowing from the land and what's in that water. We're very concerned about nutrients and pollutants and how that impacts the ocean. As you can see, here's a case. This isn't a bleaching episode, but a case where the corals have been completely overgrown. This happens on Maui frequently. Kaneohe has been well known for a long time, where the corals are completely suffocated by benthic algae that's getting its nutrients from the land, and different ways we model it through geochemistry, et cetera, so we can get an idea of how fast the material is moving and what is actually the flux, the transfer rate of the nutrients and pollutants and anything else that's in that water as it moves to the ocean. So this is an example looking down over at the Kona coast. Here's Hanako Harbor back through here. And this is infrared image. Coldest waters are the darker colors, the dark blues, the blacks back in here. So this is the harbor of the area here, and you can see there's a tremendous amount of groundwater is floating out on top of the ocean. Oh, so the ocean is red. Ocean water, normal ocean water temperature is red here. Here's the temperature scale. It's about 28 degrees Celsius. As it flows out through the harbor, as it flows out through fish ponds and anywhere else, it's flowing out and migrating across the ocean. And with it, it's carrying all these nutrients. And these nutrients, the color coding is the same because we have a linear relationship between the amount of nutrient loading that's taking place and the amount of groundwater that's coming out. This is the national park over here. So they're critically concerned about all the development that's taking place up here. There's new land use designations, lawsuits going on. This is the local wastewater treatment facility, by the way.
Let's do this for a moment. This is a heavy set of information. Let's take a break, think about this a little bit, come back and repeat some of this, but open up the door to what we want to do next.
Okay.
Okay.
Hello, my name is Kenneth Lawson. I'm your host here at Life in the Law. I'm really interested in law as I practiced it for 18 years before coming to Hawaii. I practiced criminal law and civil rights law on the mainland. Now I teach law at the University of Hawaii Law School, William S. Richardson School of Law, and I bring in guests who are very current on legal issues that affect your life here in Hawaii. Come and join me every Wednesday at 1 p.m. as we explore how the law affects you, how the law is changing, and why it's important that you should care about what's going on in your community. See you then.
There you go. Ted Ralston again, folks, Friday afternoon, ThinkTech Hawaii Studios, Honolulu. We have our fantastic guests, Dr. Cynthia Hunter, Dr. Craig Glenn from University of Hawaii. We're talking about an unbelievably fascinating subject. It's the intersection of interesting technology and really complex systems in the marine environment, which are really important to all of us here. Just at the beginning of this, I might suggest, because I'm sure many other people who could be sitting at this table and advising us as well are thinking together what we're talking about. So almost goes through my mind, you need a conference of some kind. Maybe you already have one, but I'm thinking of the 2016 World Conservation Conference and how this, in some collected way, would play in there. With Ken Kaneshiro, who I'm sure you all know up at Miley Way there. So, but back to where we were, just before the break, we were talking about what the use of the technology that you've been able to get so far has led you to see. This whole picture on the ocean of the incredible amount of fresh water coming down.
That's right, yeah.
And the consequence of that fresh water.
Right.
And the influence of development on land and probably harbor construction and this sort of thing.
That's right, yeah.
Got to be a factor there.
Yeah, there's all kinds
Maybe the sea level rise and the warming global situation.
That's a whole other big part of it, sure is.
Because this translates to the Western Pacific, where folks who depend on the marine environment more than we do here could be more severely impacted than we are here.
Yeah, right.
And then we have the social issue of how do you help them move forward?
Yeah.
And the bringing forth into this of inexpensive and almost throwaway technology of this type to help inform.
Yeah.
Then the big one is getting people who aren't involved today involved. So at the end of this, I'd like to ask you what your greatest wish would be in terms of how we can get others involved and increase the level of knowledge here. But let's go back to where we were just before the break.
Okay, yeah.
Interpreting this and have Cindy react to what you're seeing here. How would this be useful to you and Lenny Kai, for example, or Kaneohe?
This is super useful, and that's why I'm excited about working with Craig more in the future, to make the link between the land and the sea, and between the hydrology, the fresh water coming down, and the way that the coral reef ecosystem, the biology, responds to it, especially in light of climate change. So,
something I've always wanted to ask about. Kaneohe Bay was heavily harvested years ago to make the landfill, I think, for the marine base. Waikiki coral was heavily harvested for making curbs on the Honolulu streets and buildings and such, and just to make a canal, I think.
To build up.
What's that?
Just even build it up, right?
So, right. So
Waikiki.
What's the consequence of coral harvesting that has been done here over the last 100 years? Does that coral ever get a chance to regrow? The coral
It does. We don't have any before studies, sadly.
Of course.
But yes, coral does continue to grow. Some of the corals that I was showing pictures of earlier grow at a rate of about a centimeter a year, and others grow as much as maybe 3.5 centimeters a year or more. So add that up over a decade or a century, and yeah, corals continue to grow.
So they will have a chance to repopulate and generate.
Protect our shorelines and provide habitat for the fish that we
But take a look again at how would you use what Craig has produced here if we had that for Lanikai?
Well, I'm excited because we were talking earlier about freshwater coming, heavy rains bringing additional freshwater than usual into north end of Kaneohe Bay. We've seen the corals respond. What we'd like to do, actually, can I already answer your question about what I would wish? I would like for every student in the field problems class that I teach to have one of these things and a couple or 3 cameras on it so that they could go out and explore on their own, do their own investigation. Craig, you're just saying that a student could take one of these out and trace by temperature nutrient characteristics and freshwater characteristics.
Well, that's a little bit of a stretch. So that involves actually doing work in the ocean at the same time.
How could we do that?
To get the ground truth.
The connection was through the temperature. So we use the infrared temperature, and that's connected to salinity, right? And then all the nutrient flow is directly linearly correlated to each other, and so then you make that connection between the two, and you can integrate them all together, so you can get one full data set. Yeah, see how it's impacting it. So.
And then see the response biologically.
Yeah, right.
So what we need is a sensor study group of some kind that understands how we can get these sensors cheap and inexpensive but reliable. A ground truth calibration group that calibrates the sensor output against the actual measured thermal characteristics.
Yeah.
And then a connection between that and the nutrient and the botany, and biology. What a picture that would create. Now, can we get that done can we get something started by the September 2016, about 2 years from now, and have this as a major part of the 2016 World Conservation Conference?
Sure.
As well as the 2016 International Coral Reef Symposium that will also be held in Honolulu that year.
Really? What part of the year?
Summer.
And the World Conservation Conference follows right behind that. So I think the target's on the table, all right? So we better get going.
Yeah.
Okay.
So what would, Craig, we heard Cindy reversed the order here and gave her wish that she had for the future at the beginning of her third section here, not the end.
Yeah.
We'll let you do the same thing, and then we'll come back to the conversation.
So you want me to tell you what?
What would be your greatest wish about, say, the next 10 years as this understanding evolves? What would you want from the perspective of either technology, participation, multidisciplinary?
I want it all, yeah. I mean, really, I want to have a fully integrated, multidisciplinary effort that's geared towards, it's got science working at the same time as working towards stakeholders, solving problems, and combining every element that we have, bringing together biology, botany part of biology, and the technologies, their sciences, hydrology, all things together to attack specific applied problems.
What do we have to do to get to that point of this new, or maybe it's an adaptation of what you've already got in Marine Options Program?
Well, Marine Option Program is for undergrads, and the course that I was talking about, this field problems course, is also targeting at undergrads. So it's undergrads are a great link through graduate school and then into the professions.
Yep.
So our aim is the Marine Option Program's aim is to educate tomorrow's ocean leaders. So one of the tools that we use for that is to make sure that they get their feet wet, literally, and learn the technologies of the future. Learn the skills to learn new skills, I heard on the radio today.
Yeah, right.
So this kind of thing gets people really excited because the information is...
Sure gets this table excited, including our host, Jay Fidel.
Well, you get the information back so quickly, and it's so visual.
Yeah, right.
That's a good point. We found in the world of search and rescue, this changes the social dynamics because the people who are doing the work have the information much quicker and without, how long did it take us to get Lanikai measured? Half an hour.
Right.
Yeah, real time.
So there's a lot of change that's coming towards us. We need to ride that wave, not let it swamp us. We need to take advantage of it, design something, recognizing we're going to have this. Not just this thing. There's all kinds of seaborne robotics. There's underwater robotics that could be involved here. So there's a very strong robotics interest at UH, as I'm sure you both know. And maybe we need to get them in here too. I think Brian Bingham is one example, and one of the Kobayashi brothers is involved as well. So there's a connection there with engineering. And maybe we'll get them here on this table at the next time, Song Choi or one of that group. All exciting.
One thing that you've been talking about for quite some time is for people who are working on coral reefs, like my students who are looking down into the water, to look up a little bit at what's Malka. And for the people who are working at Malka on the hydrology, to look down into the water and see where it's going after that. So I just think it'd be really, really cool to get our students working together and see what kind of synergy they build. On their own.
Well, we're trying, right?
Yes.
This is like, we do share a PhD student who's actually bringing the two together, doing stable isotopes in our geochemistry labs, and he's doing it using the algae and trying to get at processes that are happening on land, impacts from land.
With Dr. Celia Smith, who's the botanist, person who studies the limu, the seaweed, who also ties all of this together.
Just the excitement that's taking place here. As I mentioned, Marty and I just got off the plane coming from this joint interagency field experimentation using these kind of systems in California. We were going through on Wednesday showing your video of the color infrared of the Lanikai Reef versus the true color, the one we just showed here. And a guy popped up, one of our new colleagues, who's in the multispectral world, and he immediately began analyzing it for us and said, not only can I help you here, but my wife can. His wife is somehow involved in a state of Florida coral consortium of some kind. And he said he'd be glad to make the connection for us. So I don't want to step in front of you guys and get in your way, but I would like to bring these additional connections in. In fact, what we can do, we can probably get either Paul or his wife in on Skype at some point in time and just share our discussion. Show Craig's pictures, show a few of yours, have them show a few of theirs, and see how they're thinking about what their challenges are.
That'd be fun.
I think Margie can check if I'm wrong here, but I think they have very similar issues.
Absolutely.
And I'm surprised that I just would have imagined the corals were highly localized and that they weren't similar coral animals all over the.
The species are different, but the responses are similar. Responses to stress are similar.
Is that interesting? Okay, that's fascinating. Now I'll throw one more on the table that might be useful to you. In February, early February, this quarterly exercise we go to in California is shifting over to Alameda Bay, and we're going to be doing maritime domain work. It's a lot of it has to do with security, maritime domain awareness, but there's also the opportunity to include the scientific component in there in terms of the marine, the quality of life, so to speak, if you're a marine animal. So as that develops, let me feed it your way, and maybe somebody can come attend that. There'll probably be 30 or 40 experiments of various kinds, similar to this, and underwater gizmos and sensors and such that might, you'll see it in a different way than I see it, and it might all be useful to this conversation. So, any closing thoughts, Craig? We've had an exciting 45 minutes here, and what did we leave out of what you wanted to tell us all about, or questions you wanted to ask of Cindy or of the audience?
Well, I think we're moving forward in the right direction. As far as what we've been doing for the last 10 years with heavy aircraft and doing infrared mapping, we're still going to keep doing it by using this new type of technology so we can constantly be going in and monitoring the changes. So these pictures I showed you were snapshots of what happens at one particular day, but it changes daily. Being able to use it as real-time monitoring is going to be a huge leap forward for us, in many, many different ways, just as it will be for the coral and for the algae, et cetera, So.
Not interrupting your thought stream, but there's some folks at Naval Postgraduate School who are thinking of the I guess you'd call it the aeromometry aspect of the mixing layer between the ocean and the air.
Yeah.
They're Navy, of course, and they care about wave formation and things like this, which are important to vessels. But they're learning a lot about that 1,000 feet and about that 20 feet.
Yeah.
Of the sublayer and the main layer of mixing. Let me make that hook for you as well. I don't know what it'll turn into.
Yeah.
But in fact, that also is a good reason to come out to this exercise in Alameda Bay in February. Closing thoughts on your part, Cindy?
Well, it's just been so exciting to learn new things as we go just this summer, since we've been doing these explorations thanks to your drone and the cameras, and you never know what you're going to see. So I'm excited to put this back in the hands of students next summer, work with Craig and his students in Kaneohe Bay, and see about making the links again between the land and the reef.
I don't want to close on a sort of a dark note, but Kaneohe Bay has had a lot of siltation over many years. I'm sure that the street cuts or the roadway cuts and this sort of thing haven't helped, and the stream modifications haven't helped. But Kaneohe Bay looks like it's going to be totally filled up in 100 years, I guess.
I don't think so.
No, you don't? Oh, good. I feel better.
I don't think so. I think most of that happened 120 years ago, when pineapple and other land ranching and other land uses totally changed the character of Kaneohe. So if it hasn't filled up yet, most of it's paved now. So I think we're going to be all right. And it winnows out. So.
Good. So we end on a strong note, right?
Yeah.
On a positive note. That's
yeah,
great.
it got bad and it.
Great.
Yeah,
and I think it's so
down.
positive seeing this energy flow here, and it's exciting to be at the very beginning of some new evolution of thinking in this very complicated domain. So I appreciate having the opportunity to work with you and having you guys come on down here today.
Thanks.
So folks, that's it for Friday. Where the road leads, one never knows where the road may lead.
Yeah, right.
This time it led to the beach parking lot and then out into the ocean from there. And let us see a little bit of the multi dimensions of this real interesting
that's great.
resource and challenge we've got. Ted Ralston, Cynthia Hunter, Greg Glenn, thanks for joining us, and we'll see you next Friday.
Thanks for having us, Ted.
Thanks a lot, Ted.
You're quite welcome. Okay. Okay. So thank you, Cindy. Thank you, Craig, for taking the time.
My pleasure.
Coming.